Hello all. In this video clip, I'll be talking about section 2.3, about dividing polynomials and the rational zeros test. So very much there are two items to be covered in this section. First, we talk about dividing polynomial. The word that we use is used what? First item, long division. It's actually what it is all about, long division. Alright, let's recall what we learned about long division back in middle school. Say we have a big number divided by smaller number, say 23, 45, 2, 3, 4, 5, nice number, divided by 13. So how do you do long division out of it? Right? I think we're going to write this way, right? And then we're going to write number 13 right here. We're going to write number 23, 45 here, and by the way, we have a name for it. This number is called the divisor, and this one right here, we call it the dividend. Alright, so how do we do long division? We take 23 divided by 13. 3 divided by 13 is, I think, 1, and you multiply it back. Let's do it quick, because I know you all know this one, right? 1 times 13 is 13. Do a subtraction. 3 minus 13 is 10. Bring the 4 down. 104 divided by 13, is that 8, I guess? Yeah, 8. 8 times 3 is 24, so 4. 8 times 1 is 8, with 2 is 104. Perfect. 0 right here. Do subtraction again, you got 0, and drop the 5 down. 5 divided by 13 is impossible, you put a 0, and then 0 times 13 is 0, do subtraction again, you got 5, and then you stop. This number 5 right here is called the remainder, and that number 180 right here is called the quotient. Okay, now in this section, we're going to do long division, but instead of working with numbers, we will be talking about division into a polynomial. So what we're going to work on is this. Something like 2x cubed minus 3x squared plus x minus 1 divided by, say, x plus 2. Okay? And similar to numbers, in order to do long division, we need what? A bigger number divided by smaller numbers. For polynomial, we need to have a bigger degree polynomial divided by the smaller, at least equal degree polynomial. Right? We cannot take degree 3 divided by degree 4. You can have degree 3 divided by degree 1, degree 2, or even degree 3 will be okay. Okay, so how to do long division on that one? Very similar to long division in terms of numbers. We're going to write pretty much the same way. The divisor is x plus 2, and the dividend is 2x cubed minus 3x squared plus x minus 1. Okay, and very similar. We take the leading term divided by the leading term, so I got 2x cubed divided by x, I have 2x squared. And guess what? I'm going to write 2x squared up here. I'm going to multiply the back. 2x squared times x is 2x cubed. 2x squared times 2 is positive 4x squared. Now that we're going to do a subtraction, be very careful when you guys do subtraction in terms of polynomials, because you may have to deal with negative sign. Do subtraction, right? 2x cubed minus 2x cubed is 0. What about the second term? Be careful. Look, this is negative 3x squared minus 4x squared. Let me write it on the side. Negative 3x squared minus 4x squared. That's going to be equal to negative 7x squared. See, that's what you don't see in terms of numbers. For polynomial, you may have negative terms in here. So negative 7x squared. And next, I'm going to drop the x down. I'm going to take the leading term, negative 7x squared divided by x. negative 7x squared divided by x. I've got negative 7x, and I'll do the same thing, minus 7x up here, multiply it back, negative 7x. Negative 7x times x is negative 7x squared. Negative 7x times 2 is negative 14x. And then I'll do subtraction again. What? Negative 7x squared minus negative 7x squared. Okay? This is where people usually make mistake because they mess up with the sign. Right? Negative 7x squared, and then subtract another negative 7x squared is negative 7x squared plus 7x squared, and that is equal to 0. Okay? What about the second term right here? X minus what? Negative 14x. X minus negative 14x. This is just x plus 14x, which is 15x. So this is positive 15x. Alright? The idea even though it's the same, but you guys gotta be very careful when you do the algebra. Don't make any silly mistakes on it. And then drop the negative 1 down. Do the same thing. 15x divided by x, positive 15. Multiply it back. 15 times x is 15x. 15 times 2 is positive 30. Subtraction, 15x minus 15x is 0. Negative 1 minus 30 is negative 31. Okay, so the whole thing right here is the quotient. Alright, of course this is divisor, this is dividend, and the remainder is negative 31. So, how do people represent the answer? I say it this way. 2x cubed minus 3x squared plus x minus 1 over x plus 2 will be equal to 2x squared minus 7x plus 15, and then plus negative 31 over x plus 2. Okay. Alright, let me write in one line, make it easier for you guys to see. Right this way. Equal to 2x squared minus 7x plus 15, and then plus negative 31 over x plus 2. Okay. Now, instead of writing the fraction, people are going to have another way to write. What if we multiply both sides by x plus 2? Left hand side times x plus 2, I only have 2x cubed minus 3x squared plus x minus 1. Right hand side, the whole quotient right here times x plus 2, we'll have x plus 2 times 2x squared minus 7x plus 15. And then this one right here over x plus 2 times x plus 2, I got plus negative 31. Okay? So the dividend is equal to the divisor times the quotient plus the remainder. Let me just write minus 31. That's okay, like that one. Okay. Say, what if, via this example, what if you have some long division that the remainder is equal to 0? And we say what? The dividend going to be equal to the divisor times the quotient only, and remainder is equal to 0, and we say that this polynomial is factorable, okay? Only apply to a division that remainder equals 0. In this case, not happening, so it's not divisible. Okay? But this is a review on something called long division. Now, there is a very special case of long division that you guys are going to use a lot in our course, pre-calculus. It's called synthetic division. Synthetic division is a shortcut of long division. Shortcut means it's faster, but it may not, it will not be powerful as the long division in the full version, because it can only apply to some special cases. And the case that we can apply the synthetic division, oh, I should not erase it, let me just rewrite it in here, is this. Let me write down. Synthetic division. You can only use synthetic division if the divisor is of the form a single x plus a number. Okay? So right now only works if the divisor is of the form a single x plus a number. Okay? So, say if you have polynomial divided by, say, 3x plus 2, I claim that you cannot use synthetic division. Actually, you can modify it using synthetic division, but it is much harder than using long division, so we don't encourage you guys to do that. And what if you have something like x squared plus 2 at the bottom like this? You won't be able to use synthetic division either. So only case what the linear divisor with leading coefficient 1, just a single x plus a number, then you can use synthetic division. And keep in mind, I say plus a number. That number could be positive, could be negative, doesn't matter, and you can use it. Okay? So on this example right here, it actually satisfies the condition for using synthetic division. So I'm going to show you how to work with synthetic division. All right? We're going to draw it this way. On the left hand side, we're going to put number -2 right here. And this -2 comes from the zeros of the divisor right here. This is x plus 2 is the linear factor, right? So the zero of this is -2. In other words, the opposite of that constant, 2. Okay? And then on the right hand side, I'm going to write the coefficients of the dividend. So I got 2, -3, 1, -1. Alright? Save some space on the horizontal line. I'll drop number 2 down. That 2 right here, bring it down. 2 times -2 is -4. You're going to add them up. -3 plus -4 is -7. And keep going. -7 times -2 is 14. 14 plus 1 is 15. 15 times -2 is -30. Add them up, you got -31. No more numbers, you stop. This number 31 right here will be your remainder. And I claim that those 3 numbers right here will be the coefficients of your quotient. So how do you interpret it? Start with this sum right here, nothing, plus, and then x right here, and then it's going to be x squared next. So the quotient is 2x squared minus 7x plus 15. So that's like the quotient in the long division full version. Okay. Let's work on another example. How about this? Great. Sorry guys, the clock is just ticking slow. Okay, we work on another example. What if we have this? 3x cubed plus 5x squared minus 1 over x minus 1. First of all, can we do synthetic division? Yes, because we have a single x and then plus -1, right? -1. So satisfy the condition. The reason why I bring up example because we did something special on the numerator, on the dividend. We are missing the x term, you see? We got x cubed, x squared, and just a number. We're missing the x term, right? Polynomial degree 3, leading coefficient 3. So to use the synthetic division, we're going to write this way. The 0 for the bottom is 1, right? And the coefficients are 3, coefficient for dividend. 3, 5, this is for x cubed, it's for x squared, and we have to write a 0 for the x term. and then -1 because we're missing the 0 for the x term, and then things get back to normal. That 0 is very important, okay? If you miss that 0, your synthetic division will not be correct. Then you won't get to the right answer, so be very careful. Again, the same thing, drop 3 down. 3 times 1 is 3. 3 plus 5 is 8. 8 times 1 is 8. 8 plus 0 is 8. 8 times 1 is 8. Minus 1 is 7. This one is the remainder, and of course, the quotient is 3x squared, I say square, right? Plus 8x plus 8. And that taking care of the first item of this section, devising polynomial. Now, we'll talk about the second item, the rational zero test. As I mentioned before, whenever people learn about polynomials, one of the biggest tasks that people want to learn is how to find the zeros, okay? And I claim that people work out on all kind of polynomials up to degree 3 and most of degree 4. However, if you have a polynomial of degree 5 or higher, it is impossible to find the zeros in general. So pretty much in here, that test will help. It's helpful to try our luck to find or to guess the zero. And let me give you an example, and I'll show you how we can try our luck. If we're lucky enough, we can find a zero. All right. So let's start with an example. F of x is equal to, say, 4. Make it easy number. Okay. How about 2x cubed plus 7x squared plus 5x. How about plus 6x then? Okay, and then plus 1. You see what? This is a polynomial of degree 3, leading coefficient 2, right? And we are interested in finding the zeros of this polynomial. In the previous section, I claimed that this is R degree polynomial, degree 3, and positive coefficient. The graph tends to be like this. So for sure, it's going to intersect the x-axis. So for sure that we do have a zero somewhere. The question is, how do we find this? And as I say, we try our luck, okay? And the rational zero test is a tool for us to try our luck. And the test saying this. What you're going to do is, you're going to take the last coefficient, 1. You're going to make a ratio with the first coefficient, in this case is 2. Okay? 1 over 2. And you know what? You're going to look for all the factors of the numerator. So 1 only have one factor, which is 1. And 2 actually have 2 factors, 1 and 2. Alright, so 1 number on the top, 2 number on the bottom. And you are looking for all the combination of the numerator over the denominator. You have a list of fractions. 1 over 1, 1 over 2. So I chose a very easy example, so we have less case to work on, okay? And then we put plus or minus in. You know what? The rational zero test says this. If you do have a rational zero, it's going to be among those numbers. Could be 1 over 1 is 1, so plus or minus 1 or plus or minus 1/2. Okay? That is all about the rational zero test. Again, there's no guarantee that we will have a zero. We have a rational zero. We do have a zero. We don't know what it is. And we try to find out the very first zero. And we hope the first zero will be the rational number, a fraction. And how do we find this? We take the last coefficient, divided by the first coefficient, that's a fraction. Look for all the factors of the top, look for all the factors of the bottom. We have a bunch of combination of numerator over denominator. We have a bunch of fraction with plus or minus. And if we have to test for rational zero, those are the possibilities. So pretty much in here, we have 4 numbers, okay, to test. And how do we test? We're going to use a synthetic division to test. Let's try 1 if it works. Let's try 1. 2, 7, 6, 1. 2 down. 2 times 1 is 2. 7 plus 2 is 9. 9 times 1 is 9. Plus 6 is 15. 15 times 1 is 15. Plus 1 is 16. This remainder right here is not equal to 0. So that means 1 right here is not the 0 polynomial. We try for all those possible 0 right here. If any of those synthetic division give us a 0 for remainder, then that will be our good choice. Try another one. -1. Let me cheat a little. -1 right here. 2 times -1 is -2. 7 plus -2 is 5. 5 times -1 is -5 plus 6 is 1. 1 times -1 is -1 plus 1 is 0. Bingo! This is 0. Remainder is 0. It means what? This polynomial is factorable. And it's telling us that -1 is a 0. And you know that -1 is 0. It means x plus 1 will be a linear factor. And the quotient is 2x squared plus 5x plus 1. So that polynomial degree 3 can be factored as what? The x plus 1 is a linear factor, and then the second factor will be the quotient right here. 2x squared plus 5x plus 1. Okay? And we find the first 0. And of course this is quadratic function. You should be able to find the other 2 0 from here using the quadratic formula.